Good morning, guys. So we're going to be looking at exponential and logarithmic functions. Starting with, let's look at this formula we have. Log A, B equals C. So basically, if we had log 381 and we wanted to find what C was, we have to find 3 raised to the power of what will give us 81, which in this case 4, because 3 to the power of 4, or 3 times 3 times 3 times 3, it'll give us 81. So 3 to the raised to the power of 4 gives us 81. So let's do another example. We're only going to do a few of these, but log 125 equals what? 5 to the power of what gives us 125? 5 to the power of 3 gives us 125. And then let's do another one. Log 2/8. This one is simple. The answer is 3, because 2 raised to the power of 3 gives us 8. Right? Okay, so what this tells us, or what we just found, is that that's very thin, A raised to the C power is B, or AC equals B. Okay. What do you get from that? I don't really know. I guess it'll help us solve for later when we're trying to find x and we have exponents. It'll help us find an equal base to cancel out, which we're going to do examples of later. But now we're going to do a few more examples of this, but using fractions. So if I had log 2 1/16, we need to find 2 raised to the power of what will give us 1/16. So I like to look at the relation between our numbers. So we have 2 and 16. We know 2 to the power of 4 is 16. But to get it to to get it to 1/16, so for it to be a fraction, it's going to be -4. So like 2 to the power of 4 equals 16. But when we flip, so the 16/1, when we flip it like this, we're basically going to change the sign like that. So let's do another one. Let's do one where our base, which is this number here, is a lot bigger than our exponent. This should actually be a little higher because that's our exponent. Okay. So let's do log 16 to the power of 2. 16 raised to the power of what gives us 2? Well, we're going smaller, which means we're going to need a number that is smaller than 1. So I look at the relation. 4 times 4 to the power of 2 is 16. But since we're going the other way this time, it's going to be 1/4 instead. So 1/4 is our answer for that. Let's do another one. So log 16 to the power of 1/2 equals what? The relation 16 and 4, or 16 and 2. You have 4, right? But you're going smaller. It's going to make it a fraction. And it's also going to be negative. Because you are going smaller, but you're going smaller to the point where it's a fraction. So it's going to be negative. Okay? So when you have a negative exponent, I'm going to write this down. So when you have a negative exponent, it flips the fraction. Flips the fraction. Yeah. I still don't really know the point of doing this, but what it tells us is kind of how to make our exponent positive by making it a fraction if it was negative. So, for example, say we had a to the power of negative n. We don't want it to be negative. We can change it, and it would become 1 over a n. And with that information, it'll kind of help us to solve for x when we have exponential functions like, like 3 to the power of x squared minus 7 equals 27 2x. So this stuff that we just did is very good practice with exponents so that we can solve for x in this case. X is an exponent, so in order to solve it, it'll be easiest if we could have them not be exponents. So in order to do that, we need to find a way to cancel out our bases, which is 3 and 27. So what I'm going to do is I need to find a way to make 27 into the base of 3. So here we have 3 already. And we know that for 27, something, or 3 raised to the power of something, so 3 raised to the power of x, say, will equal 27. 3 to the power of 3 equals 27. And here you have 2x. You're going to need to keep that 2x up here. I like to write it in parentheses because we need to remember to multiply it. Oh, so you get 6x. So when you do this, you have 3 raised to the power of x squared minus 7 equals 3 raised to the power of 6x. Now that our bases are the same, we can go ahead and cancel them out and set our set our exponents equal. So now we have this. Yay, they're not exponents anymore. So now we can just solve for x like how we usually would. You could move 6x to the left, set it to 0, and use the quadratic formula. But I don't really want to calculate, so I'm just going to find a way to factor this out by starting off by moving 6 to over here, setting it to 0, and I want to factor it out. I know that somehow I could get a common factor between these 3 terms. But in order to get that common factor, which what I'm thinking is x plus 1, I'm going to need to split up. I'm going to need to split up negative 6x. So I'm going to split it up. So usually when you write, when you get ready to solve, using the quadratic formula, you write in descending order. So x squared and then x and then your number. So I'm going to take negative 6x. I'm going to split it up to become plus x minus 7x, right? Because x minus 7x is minus 6. And plus 7 is still here. I'm just going to keep, or minus 7 is still here. And I get that. And what I'm going to do is I'm going to factor out x from these two terms and negative 7 from these two terms. Because remember, I was trying to find, try to get them to the point where x plus 1 is a common factor. So taking x out, taking negative 7 out, and that gives me x plus 1 as a common factor. So now I can just combine them and keep it as 1, and take these two and write them like this. And so now we have our x's. In this case, we have two solutions. If we set x plus 1 to 0, we get x equals negative 1. And if we set x minus 7 equals 0, we get x equals 7. So x equals negative 1, x equals 7. This is our solution set. Okay, so that's how you do that one. If you don't want to do all that, you can just use the quadratic formula. But I prefer it that way. Now let's do another example. 5 to the power of x plus 3 equals 1 over 5. Once again, we need to solve for x, which is inconveniently an exponent. So we need to somehow change our base, which, like we saw from up here, from here, you can go ahead and make this, change it so that 5 is our base and it's not a fraction. So when we do that, we'll have 5 to the negative 1. Because when something is raised to the negative power, it flips it and it makes it into a fraction. So these two are equal, okay? And oh look, our bases are the same, so we can go ahead and cancel them out and set our exponents equal, which are conveniently not exponents anymore. So now we solve it like we normally would solve, and we would get so you're gonna minus 3, so you're gonna get minus 4. So that's your solution when it asks you to solve for x, and x is an exponent. And that should be it. Bye, guys!